Hello everyone, hopefully everyone can hear me. We still have a few people joining, but the majority of people are on, and in the interest of time, I think we'll get started. Firstly, welcome everyone, and thank you for attending this webinar. This is our first in a series of webinars on performance testing. As we only have 30 minutes, this initial session is really an introduction and overview. I spend quite a lot of time delivering presentations around performance testing, and it's clear, speaking with people, that performance testing is often misunderstood and sometimes seen as a bit of an art shrouded in mystery. Often we find people have a depth of knowledge in some specific areas of performance testing, but are missing an understanding of some aspects at a high level that form that overall big picture. Today we're going to be going through the basics end to end. There's going to be a number of important take-home points, hints and tips, but the main objective of today is to bring everyone up to speed on the basics and how it all fits together. We can then build on this knowledge in other upcoming webinars, focusing on deep diving into some of the areas of detail that due to time constraints we're forced to skim over today. A little bit about me. I'm Ash Gawthorpe, one of the co-founders of Ten10. My background's in hardware and software engineering, development and architecture, and I have lots of experience in technical testing and specifically performance testing. We will be rattling through this at quite a pace. If we run over something that you don't quite understand or we're going a little bit too quick, this webinar will be available for download, so you'll have the opportunity to review it again online. On that note, if you have a question, please enter it in the chat window, and we have a section at the end where we will look to answer as many of those questions as we can. So first of all, just to get the ball rolling, what is performance test? What's the definition of performance testing? On this slide here, we have three different definitions that we use and that we actually use to teach our graduate academy. They're all valid, but the one I want to focus on is the one there in the middle. It's all about that responsiveness and stability under a particular workload. Let's look at an example application now to see what affects the overall response time. In our example app, before we can do anything like any other app, we need to log in. We enter our username and password and we click on login. The app then sends a message to the server side. Now this may be over the public internet or it may be over a private network, but suffice to say the time taken to send the message depends on the bandwidth and latency of the user's network connection. The system under test receives this message and processes it. Now processing that message uses a little bit of processor. The user session will be allocated some memory. It'll need to look up the user in a database and confirm the password is correct. All of these resources that are being used are finite. Assuming that the user has entered a correct username and password, it'll then send a message back to the application and the app will inform the user that they've successfully logged on. Now, there's a lot going on here, and we are in a sort of privileged position in that we're seeing everything that is going on, but the user isn't. The user isn't aware of anything beyond the extent of their own desktop, mobile, tablet, smart TV, whatever it is. So irrespective of how long these various components take up, the user doesn't see that. All they see is one single big lag from them performing an action to the response appearing in front of them. So far we've talked about one user using the system here, but in practice there's lots of users using the system. And as we discussed before, each user activity creates some work on that system under test or server side. A little bit of CPU, memory, disk I/O. Crucially, there's a finite amount of work that the system can support concurrently, and as we add more and more users and more load, things will start to go wrong. Users will start to see things slow down, transactions will take longer, we'll start to see errors. The system will continue to run for a while as we add load, and perhaps at that point, if we reduce the load on the system will recover and will return to normal and will carry on. But if we continue past a certain point and continue to add load, eventually the system will catastrophically fail. There's a key point here is that as we add load, and we'll come on to how we do this in a minute, we have monitoring tools installed on that system under test. These tools capture how much of each of these resources are being consumed over time. And in this way, we can then see the impact of user load on that server-side infrastructure. The trick here is in performance testing is applying representative load to see how much load your system can cope with and confirming that it's still responsive enough to meet your users' needs at that load. And also over time, as the system has more customers, more users added to it, we want to be able to ensure that the capacity that is available outstrips the demand on the system. As ever, there's a bit of a balance here. What we don't want to do is add too much infrastructure and too much capacity unnecessarily that will be underutilized, because then that's just money being spent which doesn't add any value. But at the same time, you don't want the capacity to be behind demand. How do we apply that load then? The answer is we use specialist tools designed for performance testing. Key point here is that there are many different tools. Some are open source, some are commercial, but different tools work with different protocols and support different technologies and application stacks. You need to match the performance test tool with the technology stack and protocols of the application you're testing. And it's important you do that not just for now, but also for your future roadmap too. If you're investing in a performance testing tool, you really just want to do that once. When you're selecting the tool, make sure it works with your actual application. I know this sounds obvious, but the devil is in the detail. If a tool says it supports the protocols that your application is using, that doesn't mean that it will work with your app. Very, very important that you test, demo, pilot the performance testing tool that you're going to use on your actual application instance. Let's consider what we need to do step by step then. So the first step is we need to record the transaction or user journey that we're interested in. So let's go back to login a second. In practice, you record the transaction that you're interested in by configuring the tool to capture the underlying traffic going backwards and forwards in response to that interaction. You start the recording, you perform the task through the application, in our example login, exactly as we did before, and once the transaction is completed, you stop the recording. The tool has then recorded, and also has the ability to replay, the underlying messages sent to the server that the app sent in response to login. Unfortunately, you can't just replay the recording. You've got some more work to do first. Firstly, even if you were able to replay the recorded messages, what you'd have is many users logging in with the same username and password. So this isn't representative. Also, it's likely you can't log the same user in many times, or at the very least, the app will cap the number of concurrent logins for a single user. So how do we fix this? How do we turn our recorded login transaction into one that we can reuse over and over again with as many users as we see fit? There are two separate activities we need to perform in order to do this, parameterization and correlation. So what is parameterization? Well, what we need to do is to override the parameters in the recorded message, in the login case, username and password, and make these configurable. If we do this, then at runtime, we're able to inject values into those messages under our control. Now we do this from what's generally called a data bank, which is really a configurable set of variables which you can fire into these messages. The source can be varied. It can be a flat file, it can be a database, it can be a message returned from a web service, many, many different types. And in what we often see as well is in the case where we have more than one transaction, we have parameters passed from one transaction to the other. So for example, if we had a secondhand book retail site and we wanted to search for a particular book in an online bookstore, there'll be a number of results. We then maybe want to click on one of those results and actually examine the book in detail, and if we decide we like it, we then may want to proceed and purchase that book. We've got three separate transactions there: searching for book, viewing book details, and buying the book. But crucially, we want to do those on each one on the same book, so we pass the same book ID or name or whatever the unique reference is between those three transactions. So we've now parameterized our message, but we still can't just replay the recording. When those recorded messages go backwards and forwards, when you look at them in detail, what you see is that there are various IDs, timestamps, and other fields that are unique to that particular sequence of messages. Now, these fields allow the application to work out which messages are coming from whom. Otherwise, it just sees lots of messages coming in and it can't maintain state. So if it receives a message to add a book to a shopping basket, it doesn't necessarily know whose shopping basket it needs to add it to. The key point here is that at runtime, the instances of each and every one of these values need to be replaced for each and every message. If you miss any, or if you get any incorrectly assigned, it won't work. In practice, all these need to be identified and extracted from the messages. They need to be stored, and then they need to be uploaded back into those messages when they're sent back to the server. Just to set expectations, this is harder than parameterization. In parameterization, it's normally pretty obvious which parameters need to be replaced. For login, you need to replace your username and your password, and they're generally surfaced to the user in some way. But correlation is generally hidden from you. The correlation of the IDs can vary between it being very simple and very complex, maybe just 1 or 2, up to maybe 10 or more. And sometimes it's just the same ID that's passed backwards and forwards. And sometimes they're dynamically generated by the client software, or there are timestamp which needs to be updated. And in each and every time, you need to, whatever the client's doing, you need to repeat this process and create them in your script in exactly the same way. Now, some of the tools are more helpful around identifying and potentially even replacing these parameters themselves, but I've never found one yet that just does the whole thing automatically, unaided, without any interaction. In practice, it's trial and error to make this work. You're modifying as many of those IDs, identifying them and replacing them as you can, and then you test the transaction, you fire it in and see if it works. This is one of the hardest parts, and also one of the most time-consuming parts, and one of the hardest parts to predict how long it's going to take in terms of performance testing. So we've done that now, and I appreciate I'm smoothing over quite a lot of detail here. But we've worked our way through all of our transactions we're interested in. We've recorded them, we've parameterized them, all the IDs are correlated, we have our data banks in place, and we're finally in a position where we're able to send these messages in from the server side and to be able to replay our transactions under our control, populated with data from our data banks. The very key point here to get across is that what's happening here is that the performance testing software is sending messages into the system under the test or the server side, which are exactly the same as the actual real instance of the application is doing. But crucially, it is the performance test scripts that are doing this. It is not a real instance of the application. It's not a real web browser. It's not a real fat client application. It's not a real native iOS app. But from the server side point of view, they do look exactly the same, because all it's aware of are the messages that it's receiving. So now you're at this point, what you need to do is you need to be able to take those transactions and put them together to create a load profile defining how the user volumes ramp up over time and how the volume and mixture of the scripted transactions are run. Again, the tools vary around how you create a load profile, but generally it's best practice to have a number of load profiles which are created in order to simulate different scenarios, but reusing the same transactions and data banks that you've created already. We're now at a point where we're actually able to run our performance test. So let's just have a think a little bit around what happens when we do that. So when you execute that performance test and it starts ramping up the users and it starts working its way through the transactions, the performance testing tool will record the time taken for each of those transactions, whether it's a single message or many messages, but it will provide a response time for that transaction type. It will put a response time wrapper around it. Any errors will also be captured. By doing this, at the same time as capturing and overlaying the server-side metrics that we identified before, CPU, memory, I/O, networking, etc., we're able to see the effect of how adding that user load on the system under test increases the utilization of those finite resources that are available on the server side, and also how the user experience degrades with that increasing load. So far, so good. One point though, there are some holes with this approach. If we think back to our earlier video with the components of the user journeys, one part that we're missing is the user's desktop and any time spent in the application running on, well, the desktop, the mobile, the client-side application. That is hidden from what we are recording here. Remember, the user scripts aren't actually real instances of the application. So any time taken, any latency, any delay due to perhaps poor performance of the device that it's running on, or due to non-optimal code in that client-side application, you're not going to see that, and you're going to miss it. Now, there are approaches you can take that will capture that information, but that's another supplementary approach that we'll need to run through in another webinar. So one question off the back of this. So we now understand, or at least we understand the high-level process for recording our user journeys, parameterizing them, correlating them, taking those transactions into a load profile, monitoring the server side, running our test. But how do we work out what transactions are in scope for testing? How do we work out what combination of transactions we're going to put together into a load profile, and exactly what percentage mixture of those are going to run and when? And finally, those response time targets that come back, how do we know that the application is actually performing well enough for it to be acceptable to the users? We're going to take a look at this now, but just before we do, a key point is that this is by far, I would say, the most important part of performance testing. And it's also the part which is most commonly overlooked. The most common reason for failure we see is because this hasn't been carefully considered. So people have spent lots of time on the technical side of it, recording those transactions, the parameterization, the correlation. They put it in a load profile and they run it. But what they haven't spent the time thinking about is ensuring that the load that they are running is representative of what their users are doing and representative of what other load is going on at the system in production at that time. If you don't do that, then you find yourself in a position where the results aren't representative. So essentially, worst case scenario, you look at the performance test and you predict that the system that you have is going to cope with, say, 20,000 concurrent users, and you're aware that you have 15,000 concurrent users about to use a system at some point. But then you go live and find that the system actually falls over and fails fairly catastrophically at 5,000 users. Often when we find these scenarios, it's because the time and effort hasn't gone into defining that load profile up front and quantifying that it is behaving in the way the real application behaves. In light of this then, we need to understand how we approach defining which transactions or user journeys are in and out of scope, how long they should take to execute, and what blend of transactions should be applied to the load profile and how the users ramp up over time. We'll cover a number of very high-level important points here, but we'll run through these one by one. So first things first, how do you define which transactions are to be included? As a rule of thumb, you want between 10 and 15. You don't want to overcomplicate it, but at the same time, you don't want to oversimplify the number of transactions you're choosing either. We decide on which ones to use based on how important they are to the business, how often they're run, and what's the risk if they fail. So here's an example sort of user journeys for an example retail application. Most of these should be known to most people here. Most people are familiar with using retail applications. We now need to define the response time parameters. Crucially, these need to be objective, measurable, repeatable metrics, because we'll use these to work out whether performance is sufficient for each one of those transactions. It's no good having something which says, well, it must be fast or it can't be slow. So here's an example. The different tools tend to converge on a fairly standard set of metrics. As you'd probably expect to see, you have min, max, average, by which we mean mean values here, but there are also the percentiles. These are the most useful, so let's just look at 90% as an example. So if you run a performance test and you capture 10 timings for a particular transaction, and then you sort them all by response time from min to max, the 90th percentile in this case is the 9th longest running transaction. These are very useful as they show how the timings vary. For example, if login takes 15 seconds on average, but the 90th percentile is 2 minutes, and the 99.8th percentile is 4 minutes, this is a wide spread which will be more concerning to the user than, for example, whether the average time is 14 seconds or 15 seconds. So how do we go about calculating these values? Our advice is to work very, very closely with your stakeholders. You want to run through each transaction with them And I'd recommend recording a video of that transaction being played on the application and then slow it down or speed it up. There are many open source tools that allow you to do this to show the different transaction response times. So this allows you to show them the difference, and it promotes a dialogue and understanding far beyond just putting numbers in a table. Crucially, they need to sign off on this, and they need to be happy that if these criteria are met, then the system is performant. You don't want to be in a position where the system is meeting those response time targets. You then go live and the production monitoring shows that those response time targets have been met as well, but then the product owner is saying, well, this is too slow. That's not the time to find this out. This is the time to have that conversation and really get them to define what it is that it needs to do, what is good enough. In terms of load profiles, what we recommend to do is to have a number of these. As we mentioned, the load profiles are built up from the transactions, the data banks that you've recorded already. So they're relatively quick to put together. You want a number of these that represent different peaks in demand at different times. So for retail, for example, this may be a normal day, an end of season sale, Black Friday. For a law firm, it would be a sort of normal day, month end, year end, etc. It's a question of bringing those together and then putting them into a number, again, maybe 3 or 4, maybe 5. It's that kind of level of different number of load profiles that you're looking for. Now, this deserves a topic in its own right, and is one that we'll revisit in a separate webinar. In order to bring all this together then and actually run those performance tests end to end, let's just have a little recap on what it is that we need to do and how it works in practice. So we identify the key processes and user journeys in scope. We create the load profiles. We set the non-functional requirements and response times for the applications. We script the transactions with the parameterization and correlation that we discussed. We confirm that the environment and the data is suitable. Now, there's a lot of complexity there. We'll revisit that later. You then go into this cycle of executing the performance test, reporting on the results of the performance test, analyzing those, tuning any problems that you find, and then once you've done that, re-executing the performance test to confirm that there's been a positive improvement in performance. That test, analyze, tune cycle, we do a number of those, but up front you don't know how many cycles you're going to require. There's a lot of different parties involved in that. You run the test, you run the analysis, that's quite quick to turn around. You identify bottlenecks in the system where you see the points where the user transaction times are slowing down, and you start to see resource constraints on the system, those bottlenecks that you can identify and try to engineer out. But identifying and resolving those bottlenecks often requires a number of teams working together. It requires time, and in all likelihood, it will then require a release of the software which needs to go back into the performance environment before you can then retest. So it's essential that you factor that into your plans when you're considering how long this is going to take. I'd just like to consider some common pitfalls and problems that we see fairly regularly and that we encounter when we're doing performance testing with clients. So I'd say that these are split into 2 categories. The first category are the things that will stop you executing your performance testing, or at least slow down the pace of that performance testing. So these are the blockers. So there are things like data issues where the data doesn't tie up, for example. So your scripts are trying to search for particular items, add items to baskets and pay for items, and the data isn't aligned. So maybe that the items don't exist, or there aren't enough of them, or they don't tie together. So when you try to add it to the basket, it doesn't work. That's a scenario we see quite often. Environment's not ready. When you do a smoke test of the environment when it's first available, so this is a low-level test just to make sure it works end-to-end, we often encounter a number of problems there. When you encounter those problems, they then need to be resolved, they need to be investigated, and that can be quite a sink of time before you're actually able to execute your performance tests. The next point around being able to script certain user journeys. And this is most commonly caused by the correlation not working, as we discussed earlier. This again can be quite a sink of time, and something that needs to be considered and planned for fairly carefully. Delivery of software. So this is delivery of software for you to test against, always late. Very rarely I find this software delivered earlier than the date that it's expected to be delivered. Licensing. So the performance test environment that you are running the performance test on, the licensing needs to be in place. We work with clients often that use Citrix or other sort of virtual desktop sort of tools. Often the licensing isn't in place in those environments to support the level of load that we're wanting to put in there. And finally, just general orchestration, pulling all the pieces together. There are a lot of different parts at play here, all of which need to come together. And that can be quite tricky, quite time consuming, and also require a lot of people just to get all the stars to align so you're able to run your performance test. So that's one set of common pitfalls and problems. The other ones are perhaps the nastier ones. These are the ones that won't stop you from testing, and you will get test results out, but the results that you get will not be representative of what you see in live when the system goes live. So these are perhaps the nastiest ones because they're really storing up problems further down the line. So the common ones we see, the environment's not being live-like or live enough. This again warrants a webinar in its own right. The differences between a performance test environment and a production environment. How scaled can it be? If it is scaled, how do you apply scaling factors to the results that you get to interpret how it will perform in live? The data not being representative. In order to do performance testing, you need a lot of data. It needs to be a representative amount of data, and also the structures that exist within that data also needs to be representative. It can often be oversimplified. One alternative there is to copy it from live, but then that can have its own problems around obfuscation and around data security. Load profiles not being representative. I think we touched on this before, but the load profiles have to truly represent what your users are doing in live. Now, if you don't have any metrics or any analytics around how the system will behave if it's a new system, then that's fine. But what's really important is that you retrofit a load profile from the data that you have after the system has gone live. And then there's a couple of others really here around information that you're provided with. Oh, well, nothing's changed in that component, so nothing will have changed there around performance. Or the descoping of third parties, simplifying things to remove third-party interactions, things like payment providers, which can cause problems. And finally, not considering batch jobs and other running processes. You're adding load to the system generally through the front end and maybe through other couple of entry points, but also there can be load added to the system when it runs certain jobs throughout certain points in time. Those need to be understood, carefully considered, and added to the load profile as well. And that's really all the slides and all the information I think we have time to provide today. We still have a little bit of time. So at the start, we mentioned that we would look to see the questions that were coming in and try to answer some of those. We have had a few questions in. Just take a quick look at these. So there are quite a few that seem to revolve around tools. So the questions around what tools do you use, particularly for different application types and the different protocols that they use. The answer to that is that we use a variety of different tools, sometimes open source, sometimes commercial. There are a lot of tools now converging on HTTP, since more and more applications just generally use HTTP rather than other protocols. And so if your apps are using those, then you have quite a wide level of support. If your apps are using something a little different, maybe there's some sort of bespoke binary protocols or something else in there, then a number of the commercial tools, chances are, will support that, but you will pay for those, and the number of tools that you have available to you diminishes significantly. But again, it really comes down to that point of using the right tool based on your application type and the protocols that it uses. There's a few questions here around how do you build out a performance test environment. This really does warrant another webinar in its own right, but it's really around, it needs to be representative. That's the important point. If, for example, you maybe have a live environment with 10 nodes serving your web tier, in terms of the performance test environment, you can get away with maybe, say, 3 to save cost. But if it is load balanced in that environment, what you really don't want to do is just use 1 and avoid that load balancing. So there's a number of things that need to be considered there. And also there's another point around the different third parties and how you either integrate those or you stub those out. But again, that would be considered as part of a separate separate webinar, and some of those specific questions we will respond to directly. I think I mentioned at the beginning that the webinar is also available for playback and download. So if people would like to download that and review that in their own time offline, obviously you're very, very welcome to. I'd also like to say that if you have any questions on the content covered, or if you have any specific performance testing questions or queries that you'd like to discuss, then please do get in contact with us and we'll be very happy to talk it through with you. Also, any feedback around this webinar and also around what you would like to see in the future for future webinars, that would also be very useful information, because then based on demand that will guide us around what we look to do next. But that's everything from us. So I'd just like to say thank you very much for attending today. I hope this has been useful. I hope it's been informative. And thank you very much for your time, and we look forward to running the next one and hopefully having you joining then. Thank you very much. Thanks. Bye.